Hey class, welcome back to the unit on circles. Today we're going to talk about all the things that can happen when we start working with inscribed angles. And these are going to be a little bit different than our central angles. And so we're going to have to pay attention to some of the differences here, and we're going to work a lot on that. So here's our video lesson for inscribed angles. We're going to talk about the inscribed angle theorem and then all the other neat things that can happen from that. And then we're going to work with it to find measures of stuff. So let's get into notes. All right, so what is this inscribed angle all about? So you got to pay attention to see this is an inscribed angle. It's an angle that's made from two chords inside a circle. Okay, so it's an angle that's made from two chords inside the circle. Now, once that happens, a whole bunch of stuff will start occurring. The first thing we need to do is pay attention to the difference between the central angle that we're used to seeing and now the inscribed angle, which is made from two chords. Now, in the central angle, life was so much easier because the arcs were the same measure as the central angle, and everything was so much easier. But now we have an inscribed angle, and stuff gets complicated. We got to deal with halvesies. Uh-oh, halvesies. So if you have an inscribed angle, okay, the inscribed angle, it's going to be half of the arc. So the angle is half the arc that makes the inscribed angle, okay, or the arc that is intercepted by the inscribed angle. So that's what's interesting. The angle is half the arc. And with that, a whole bunch of stuff starts to occur. So we have these things called corollaries. And we look at the first corollary. And did you know that the two inscribed angles, right, that intersect the same arc, right, those two inscribed angles, they have the same arc right there. So each of those angles are congruent to each other. Now here comes an announcement. Perfect timing.
Jamaris, please report to 803.
So we have our case where if we have two inscribed angles intersecting the same arc, then the angles are congruent to each other. Okay, that makes sense, right? Based off of this first note, this totally makes sense because if you cover one angle, all right, well, that makes sense, right? Then you cover the other angle, I get it out, right? So it's making sure that we see inscribed angles and arcs. Now, what's going to happen with this other corollary? It's about a 90-degree angle or intersecting the arc that is a semicircle. So if we look at an inscribed angle that makes a semicircle, that's 180 degrees, right? The semicircle, the arc is 180 degrees. So therefore, the inscribed angle is a 90-degree angle. Okay, so the inscribed angle is a 90-degree angle. So those are kind of those are neat to recognize immediately. We don't need the diameter of the picture here per se, as long as we could assume that that would be going through the diameter. So you know that the inscribed angle is 90 degrees because it makes the arc. Now here's a really fancy corollary. If we have a quadrilateral inscribed, then opposite angles are congruent. So how does this work? Let's take a look. We really want to focus on opposite angles here. So let's take angle A. If we're going to look at angle A, when we focus on that angle, can you see the inscribed or the arc that it intersects? So that's going to be the hardest thing. Can you see the arc that angle A intersects? That's a hard arc to see. Angle A intersects arc BCD. Okay, so we got to be able to see that. Now, this particular corollary talks about the opposite angles. And so when we look at the opposite angle of A, that's angle C. Now, when we look at angle C, do you see the arc that it intersects? Hopefully you can see the arc that angle C intersects. It's the rest of the circle. It's the rest of the circle. So both of those angles together, both of those inscribed angles intersect what turns out to be the entirety of the circle. And since both of them intersect the entirety of the circle, both of them intersect 360 degrees. And as we know from our inscribed angle theorem, the inscribed angle is half the arc. Okay, so since the inscribed angle is half the arc, these two angles together are 180 degrees. They are supplementary. So A and C together is supplementary. And the same thing occurs with angle B and angle D. if we look at angle B, okay, if we see angle B, what is the arc that angle B intersects? Hopefully you see it is ADC or CDA. And then when we look at the opposite angle of angle B, it's angle D. Hopefully you see the arc that it intersects, the rest of the circle, going from A to B to C. And again, together that's all 360, and the inscribed angle is half the arc. So those are the notes we're going to talk about today. Let's do some practice, and we're going to refer back to that quite a bit. So here's our deal. We have a circle going on. Seeing the angles and the arcs is the hardest part. So really, it's all about, can you see the inscribed angles and the arcs? That's going to be the hardest thing. Can you see the inscribed angles and their arcs? So if you can see that, well then a lot of things can start becoming simpler. So here, we're looking for the values of A and B. Now, A itself is an arc measure that makes it out to there. Is there an inscribed angle that makes A? And yes, it does. Hopefully you see that the 60-degree angle is what intercepts A. You need to be able to see that. That's the most important. This 60-degree angle intercepts A. And as we know from the note, the angle is half the arc. The angle is half the arc. Okay? So with that knowledge, okay, and again, this note, angle is half the arc. Okay, it gives you this formula, which is fine, but this is what it means. The inscribed angle is half the arc. So that means we have now algebra can come out to play. Okay, so what does that mean? That means 60 is half of A. Well, that's exactly what it means. So since 60 is half of A, well then what is A? A is going to be 120. You know, algebraically, you multiply both sides by 2, whatever. It doesn't matter. But we find out that A is 120 degrees. So we have now found the measure of A. So now that we know that A is 120 degrees, well, what's the deal with B? Okay, so here's the deal with B. So we're looking at angle B. Can we see the arc that B intersects? And I hope you do. B intersects PTS. Okay, so B intersects all the way from PTS. Okay, so now, can we figure out what the angle measure or the arc measure of PTS is? Remember we just found A to be 120, right? And this little arc here from T to S, arc TS, is 30 degrees. So what angle B is intersecting, okay, so angle B, or B degrees, intercepts how many degrees, right? That's the question. Angle B intercepts 120 and 30. So angle B intercepts 150 degrees. Okay, so if we see that, if we say angle B intercepts 150 degrees, and we know that the angle is half the arc, okay, so now we have more algebra. The angle is half the arc. So B degrees is half of 150. So therefore, we now know what our B is. B is 75, half of 150. So there, we can find the values of A and B. And so it's seeing the inscribed angles. That's the hardest part. So now we look at our second one. In circle O, what is the measure of angle A? Now we know it's circle O. So that means O is the center, which means makes this the diameter. So if we have our diameter, we now see that A has to be 90 degrees because it's intersecting the semicircle. Okay, so that has to be 90 degrees. It's intersecting the semicircle. And the inscribed angle is half the arc. Half of 180 is 90, or we even had the entire, there's a specific note about that. Okay, so we even have that specific note. So that makes that a little bit straightforward. And we got to remember that. So as we remember that, we can move on to a couple more examples. Okay, so there's another diagram with an angle in there. And the question is, what is the measure of angle 1? And so we look at angle 1. Now here's angle 1. It's tucked in here. And we have a 40-degree arc here and a 70-degree arc here. All this stuff is going on. Now we can find out a bunch of information, but why work so hard? Because did you notice that angle 1 is intersecting a semicircle? Angle 1 is intersecting a semicircle. What does that mean? That means angle 1 is 90 degrees. So it's important to recognize where those right angles are. Let's make it a little bit more challenging, shall we? Okay, so now what is the measure of angle 2 in this second question? So here's angle 2. Do we see the arc that angle 2 is intersecting? And yes, hopefully you see angle 2 is intersecting the arc there that I've kind of ran over in blue. Now, is there any other angle that intersects that arc? And the answer is yes. Take a look. That arc is also made from another inscribed angle. That same arc is made from another inscribed angle. And that inscribed angle is 38 degrees, which makes angle 2 the same measure. It is also 38 degrees. So you got to be able to see that as well. And again, that's one of our corollaries, our first corollary that we discussed in notes. So that's that corollary in action. All right, last example for today. We're gonna knock out this diagram here. We're going to see all of the measures of the angles. So hopefully you're looking at this diagram. You can already tell two real straightforward angles that we can find. Hopefully you know that we can find angle 1 and angle 3 super duper quickly. Because angle 1 and angle 3, if you look at angle 1, do you see the arc it intersects? A semicircle. Angle 1 must be 90. Angle 3 also intersects a semicircle. Angle 3 must also be 90. And does that jive with what we have learned? Yes, it does. Because those are opposite angles, and they are indeed supplementary. So that makes life easier. They're opposite angles, and they're supplementary. So now, what's the deal going on with angle 4? So look at angle 4, because that's going to be another angle we could easily tackle, I think. If we look at angle 4, this should kind of be a little bit straightforward. Here's angle 4. Do you see the arc it intersects? Angle 4 intersects all the way from angle 1 to angle 3. So angle 4 intersects a combined total of 140 degrees. Okay? So angle 4 intersects 140 degrees. And as we know, the angle is half the arc. And since the angle is half the arc, angle 4 is 70 degrees. So we now have unlocked angle 4. And with angle 4 comes angle 2, because we know a couple of things. We know, well, first of all, we can do this a couple ways. We could see that angle 2 intersects the arc length that's, well, basically not 140. Right? So angle 2 intersects not 140. So we can subtract 140 from 360 and see that angle 2 intersects 110. So you know the arc, 220. You know the arc measure of what angle 2 intersects. So we can see that the angle is half the arc. We know the angle is 110. We can do it that way. Or we can remember, again, opposite angles of the inscribed quadrilateral are supplementary. So that means angle 4 plus angle 2 is 180 degrees. Okay, or we could look at it that way. Angle 4 plus angle 2 equals 180 degrees. And since angle 4 is 70, angle 2 must be 110. So it doesn't matter how we arrive at unlocking all of those angle measures, we can still get there. Okay, so that's it for this video right now. We'll come back in another video and do some more stuff with inscribed angles, but that's the general, the general notes of it. And the most important thing that we can remember for this is that the angle is half the arc. And so that's going to be, the inscribed angle is half the arc. And that'll be important for later. So we'll come back for more. See ya.